Muligheter, ikke sant, til å støtte nye produkter, og da, jo mer teknologi vi har med oss da, jo senere blir vi, og vi blir jo utkonkurrert til slutt, ikke sant. Så har vi utvikleren, har også en del behov. Han må da som en konsekvens av det her skrive komponenter, om det en app eller om det en server eller noe middleware eller hva som helst, så det jo snakk om at riktig verktøy for jobben tvinger fram det at man må snakke sammen i forskjellige språk, programmeringsspråk. Og for dem som vant til å jobbe med webapplikasjoner, så det en helt annen verden, og det å shippe kode inn i en App Store, og da miste kontroll over det. Du kan ikke hot-deploye en fix hvis du glemte av noe i siste liten. Så stabilitet og sånne ting blir veldig viktig, og i tillegg så har du ikke nødvendigvis kontroll over hvilke versjoner av applikasjonen din som finnes. Så du må være veldig bevisst på når du kan, la oss si at du skal oppgradere refakturere hele serveren din, og du må kvitte deg med noen gamle versjoner av klienten din, fordi det for mye jobb. Så det en avgjørelse som du må ta veldig bevisst, ikke sant? Kanskje må du la dem som har så gamle telefoner at de ikke får oppgradert til din nye versjon. Hva skal du gjøre med dem, ikke sant? Så det her med å håndtere kompatibilitet blir enda mer vanskelig da. Ja, så det her jo egentlig mer om akkurat det der, at du får i praksis forskjellige protokollversjoner av API-en din, etter hvert så systemet utvikler seg. Det ikke jeg som har tegnet her, det datteren min på 14, som har drømmer om å bli illustratør, så jeg får prøvd seg nå. Så i dag så den vanligste måten å deale med det her, det at du lager en såkalt restfull API, og da det JSON som formatet vi koder informasjon i, og det veldig populært. Det blant annet fordi at det veldig populært. Alle andre gjør det, så du gjør det. Det enkelt, gjennomsiktig. Du kan bruke den såkalte curl-kommandoen til å gjøre en one-liner på kommandolinja for å simulere en request og se på responsen. Du trenger ikke å drive på så det relativt transparent for deg som utvikler. Og så handler det jo egentlig om å manipulere ressurser, det her med REST. Ikke sant? Det jo doktoroppgaven til Roy Fielding, som han var vel leder i Apache Software Foundation helt i begynnelsen. Det var hans paper, avhandling, som var grunnlaget for det her paradigmet, da, REST. Og så det mye diskusjoner om at ja, nei, det ikke ordentlig REST hvis du gjør sånn, og sånn som ikke bryr seg. Ikke sant? Men noe av det som clouet med JSON jo at folk, på samme måte som XML, det må være well-formed, ikke sant? Syntaksen riktig, strukturen fullstendig wild west, ikke sant? Du kan gjøre akkurat som du vil, og det veldig nyttig til noen ting, men du skyver jo en del problemer foran deg. På samme måte som i dynamiske språk, så får du en større load på testing, fordi at compileren kan ikke gjøre like mye for deg. Så det at du bruker JSON betyr at du har i praksis ikke et skjema. Det finnes jo systemer for det, men noen som har prøvd JSON-skjema? Noen som likte det? Nei. Og det litt samme med XML også, ikke sant? XML-skjema. Syntaksen jo ja. Så jeg vil si at skjema, hvis du skal ha det perspektivet at applikasjonen din skal leve lenge, så skjema bra. I tillegg så må du tenke på dine interne tjenester. Har du egentlig lyst til å drive på og gjøre typekonvertering til og fra JSON mellom ting som skrevet i Java overalt? Og så innser du kanskje at ja, det jo egentlig RPC jeg vil ha. Den restmodellen jo bare noe jeg driver på å skohornet RPC-en min inni. By the way, anybody who doesn't understand Norwegian? Okay. I apologize. The slides were in English, so I can do the rest of the talk in English. Okay. All right. So one issue we ran into at Sedge was using JSON in a strongly typed language, such as Java. The very first JSON parser that you got, the JSON.org one for Java, looked like this. So you just get an object, the JSON object, you have methods to access the contents of it. And if you do something, if you ask for a string but it contained an integer, you will get a runtime exception. Right? And then, we add some magic around it. So somebody writes an annotation system so that you can automatically bind these JSON fields to properties. But still, it's just a more fancy example of the same. And some people may go as far as just to use reflection and use POJOs and just map the JSON fields straight into it. But the fundamental problem with this is that you get all of the error handling at runtime. There's no, if somebody makes a typo, which of course your tests should cover, but if they make a typo, you won't catch that until the application is running. Normally, you should be able to catch that at compile time. Right. Another problem with JSON is, can we remove the thing on the top? Type conversions. And that's an issue for all kinds of serialization frameworks, right? So specifically to JSON and JavaScript, you might have problems with float precision. 64-bit integers have been known to have issues. You basically lose precision there also. And there's no way to represent binary data in JSON. It's UTF-8 or nothing. Right? So then you end up base64 encoding and doing all kinds of hacks, but yeah. So I'm going to talk about Thrift and ProtoBuf first. Those are based on an IDL. An IDL is the interface definition language. It's a term that is more than 20 years old. Anyone remember Corba? DCOM? Yeah. So those were early concepts around the same idea. But that was built around a completely different way of thinking about objects. Corba was about finding remote objects and doing stuff with them. So we tried to wipe away the process and network boundary. And that didn't turn out to be practical. And also it's completely, utterly complex. So today we have two primary systems that do the same thing. There's tons more. But I'm mostly going to focus on Thrift, but I'm also going to show you examples of how the same thing is done in ProtoBuf. So this is just a way of representing a user. It's kind of a model. Let's see, this is the pointy thing. Mm-hmm. Yeah, there we go. Okay, so actually I can do this. So this is the main type, right, the user. It contains another type and so on. And then we have names of the fields. So if this was JSON, this would be all the information you had. You have names of fields, and then everything is implicit. And you have to enforce those things by writing tests and scaffolding around your objects. But then you add type information, both about the data type itself, and also there's this concept of optional and required. and in ProtoBuf there's something called repeated. So here we know more about what possible values these fields can have. And then there is these numbers. And these are important because that's how you can provide a mechanism for deprecating fields in the long run. So when this thing goes over the wire, it doesn't use the names to identify the fields. It uses these numbers. They're called tags. Okay, so just quick list of the types you have available in Thrift and protocol buffers. So as you can see, Thrift has these more collection types here. ProtoBuf doesn't have that, so you use another technique to achieve the same thing. But these things are pretty handy. And also, if you have experience with C++, you will notice that there's a clear C++ bias in that you have unsigned, signed variations of all the integer types. Okay, so on optional versus required versus repeated. Required fields are required. That means the object isn't valid if it's not present. Thrift has something, I didn't show that in the examples, but if you just omit this part, then it becomes optional in, but required out. So it tolerates not having the field present when you read, but it's always going to populate it when it writes. And then repeated is the way ProtoBuf handles lists. So if you, let's see, oh, it's not here. Okay, so in Thrift you would do list phone. Here you do repeated phone. So it's just a slightly different way of doing the same thing. One thing to know, though, is that if you have a field that is required, you're stuck with it. There's no way of deprecating that. And while it seems like a good idea when you start defining these protocols to have stuff that is required, because it makes sense, you probably shouldn't. Because if you need to evolve the API by adding new fields that change the behavior, then you still have to populate those required fields. And the ProtoBuf team has realized this, and they simply removed the support for these required fields in version 3. Okay, so nitty-gritty. So this is the binary encoding. And the reason I'm showing you this is to help you understand how you can get compatibility across versions. So this is basically this struct, this guy with a name. He has an ID. There's no string, no email, and there's 2 phone numbers. So we start off with a type ID, which is a single byte. And then we have the tag, this one. It says, and with these 3 bytes, so the code reading this might say, I don't know that tag. But since you know the type, you have enough information to skip it. You know how many bytes you have to seek forward to find the next entry. So in the case of a string, that means you have to read the length. And here you have the bytes. It's not 0 terminated, it's the length, and that's always 4 bytes. The ProtoBuf format is conceptually similar, more optimized, a little bit more compact, but definitely harder to read if you get a screen full of hexadecimals. So this is the name of the guy, Nils O. And the next field has the type. This is a type ID for 32-bit integer. This is a tag ID, which is this one, right? So now we have those. And then you have just a value. And the next one is a list. This is a type ID for list. This is a tag number, this one. And then you have the type of the elements in the list. So it's a list of structures, and the structure type ID is 12. It has 2 elements, and then we have the fields of the first one, and a stop byte, fields on the second one, and a stop byte, and so on. Okay. The thing is that nowhere here is a mention of the names of the fields, right? So if you need to change the ID to a string in the future, because you have to convert using UUIDs or something like that, then you can do that. But you have to create a new field. You can rename this one to deprecated ID or whatever, and you can even remove it since it's optional. And then you add a new field, let's say 6, optional string ID. And what that does is it breaks your compile. That's fine. You know, you can just change the code, recompile, and it works. But it doesn't break the decoding and encoding of the existing servers and clients. Okay, so here's an example of that. So let's say the client's code was compiled with this version of the protocol, and the server side was compiled with this version. Here you can see we have fields A and B, and here we have B and C. So this one doesn't have C yet, and here we have removed A. Right? So when the message goes this way, the server doesn't know about A, or the field with the tag 1, but it knows how to skip it, so it just ignores it. Right? And if you send a response back with C in it, with tag 3, the client doesn't know about it, but it knows how to skip it. So you have to have some checks and all that, but at least the protocol is not going to break. Okay, so let's try to have a little quiz. Does this change break the protocol? Hands up if you think it does. Yeah, that's right, it breaks the protocol. If you have something required and it changes it to optional, if you compile a new client with a new code that has optional, it's not going to send that if it's not sent. And then the server receives that request, and then it's going to throw an exception. Right? So you cannot do that. What about this one? The other way around. Who thinks this is going to break the protocol? It's going to break the protocol. So again, if you deploy a new server which has the required field and the old client has the optional version, the client is not going to send the field that the server expects to have. It's going to break the protocol. What about this one? Who thinks this breaks the protocol? Okay, it's fine. Because what identifies the field is the number. You can change the name of it safely. It breaks your build, but it doesn't break the protocol. Okay. Oops. Kind of gave that one away, huh? So, here I'm just changing the ID, right? That doesn't work because it's required. Okay, so enums. We saw that briefly in the first full example. Enums are just represented as integers in the protocol. But can you change the name of the symbol, you think? Is that going to break the protocol? Okay, you're so silent. No, it doesn't. It breaks your build, but it doesn't break the protocol because the numbers that go on the wire stay the same. And finally, here we have changed from 32-bit to 64-bit integer for the same field. Is that going to break the protocol? Yeah, of course. Oops. So This is basically a list of things you probably shouldn't do. But it's okay to rename stuff, but never touch the type, never touch the tag. Okay, so lots of ideas and concepts going around now. So let's look at how the IDL is converted to code, because that's what we need at the end. So this is your Thrift source. You run that through the Thrift compiler. And here we generate code for Java, C#, and PHP. And we have some options that say, creates JSON serializers and add validation code. And you have lots of options for these things in the other languages too, if you want to have bean-compatible objects or use Android, parcelable, and so on. And then you get source code in 3 different directories with a given structure for each language and all that. And then now it's your responsibility to compile this and so on. So the reason we started using Thrift instead of ProtoBuf in Sedge was basically language support back when we started. Today I would probably consider protocol buffers more. But Thrift has built-in support for a whole ton of languages. Protocol buffers have a plugin system, so you can write code generators for it. And that's great. Problem is that the Google guys made nice model objects that were immutable and were consistent about that. While many of the third-party plugins, they just make setters and getters and all kinds of. So it's not as consistent. The Thrift stuff is more consistent. So even if it doesn't say yes here, you will probably find third-party plugins for all of them. If you need ActionScript, I don't know. Okay, so now it's more about how we interact with the model objects themselves. So here's the phone number class. Thrift generates setters and getters. If you have a problem with that, you can write your own generator. We are currently working on one to see how that works out. And then you have writing and reading through something called the protocol. So that's an implementation of the binary protocol. There are also other protocols encodings. So there's an interface and different implementations for this. So the way the reading and writing handles is done in Thrift is that you have your class, the one we saw on the previous slide, and you have read and write methods to the protocol object, which contains a transport. The protocol object just has read and write. The transport knows how to fetch certain types of fields from the underlying I/O system. So the protocols, there's encoding implementations. They're pluggable. You can write your own. There is 3 standard ones: binary, compact, and JSON. The difference between binary and compact is this one is a bit more CPU intensive, but produces smaller payloads. The JSON one is just a hack to make stuff work in the browser. Binary is the most common one, yeah. So the transport, that's your I/O plumbing. That's how you read and write to requests if you run in a web server or if you run on a plain socket, anything. And you have multiple implementations, such as the HTTP client. You can just read from files or from memory. Read and write to memory to encode stuff. And then we have transports wrapping other transports. Such as the framed one, which lets you encode many messages in the same transport. Yeah, and you probably want to write your own if you have a certain way of doing authentication or something. So we're running out of time. So now we are at the RPC part. So here you have a very simple service. You have a say hello method. I'm going to rush through this now since we are out of time. This is a PHP example of how you implement that service. So you just implement the interface that is in the generated code and implement the method and return the response. And here's the boilerplate you need to have in some server accessible file to run it. Same thing. This is the Ruby client for the same service. So first you have to get the transport and the protocol and the client implementation. You open the transport. You send a request and print a response. Yeah, okay. So I just want to mention that this is actually, having these interfaces is actually pretty nice if you want to be able to take your service and break it out. So today people talk about microservices, right? And you may or may not want to do that, but if you find some kind of boundary within your application where you see it's probably going to make sense to break up this service at some point, you can start using this interface internally within your single process application. And then you can just switch around and use a remote application once you're ready to break it apart. Okay. Questions?
You said you were going from Thrift to ProtoBuf?
No, I said that today ProtoBuf has more of the features that at least we would need. There is a framework called gRPC. So first of all, 5 years ago, ProtoBuf didn't have RPC. It's only the encoding and decoding. Now today you have something called gRPC, which is bleeding edge HTTP2 streaming APIs. So, but it really boils down to the languages you need to support, I think, still.
So why would you even consider ProtoBuf compared to? Does it seem more expensive?
So Google has a lot of experience, and there's tons of hard-learned lessons in that system. It's a bit faster, a bit more compact. You have immutable objects. And it's, yeah, again, I'm not saying we would use it. I'm saying I would look more closely at it this time. Yeah. So if you are doing C++, then probably ProtoBuf is really a better option, for instance. Yeah. That's an Apache project. So there's an Apache. So they have committees with committers and so on. So it's a fully standalone Apache project. I have a link for here. Okay. Thank you.